Hi everyone, we're trying something different again today. Was having trouble with the iPads. Go figure, trouble with the iPads. So I'm trying my desktop camera here. Fingers crossed there's no problems with this. What I wanted to talk to you guys about today is something called density. And we're going to see what objects sink or float in this huge tub of water here. Now when I'm talking about density, I'm talking about how compact or close together the molecules are in an object. And I know with first grade we talked about the molecules in solids, liquids, and gases. And we said the solid molecules, they're packed together real tight, almost in an organized manner there. The liquid molecules, we did the liquid molecule dance. They're kind of more free-flowing. They're a little more spread out. And then we did the gas molecule dance, and they were really stretched out, really free-flowing, easy to fill the container, just like the water, but even more so. So those molecules are moving around even crazier than the water ones and very spread out. So density, we said, was a measurement for how compact, how tight those molecules are in an object. So, and it has something to do with how heavy an object is for its size. So the objects I'm going to test today, I've got a gourd, a ping pong ball, a cap eraser with a smiley face, pine cone, basketball. I've got a Coke Zero can of pop, and it's got 0 calories and I believe 0 sugars in it also. I'm a Coke Zero kind of guy. And I've got Wild Cherry Pepsi, and it has 160 calories in it, and it contains, where does it say the sugar? I don't see it where it says how much sugar's in there. I see 30 milligrams of sodium. Oh, 42 grams of sugar. So, is there a difference? They feel very similar to me. What will float, what will sink? And I also have a marble and a toothpick that we'll try out also. So what I would do is kind of have some predictions ready. Do you think certain items will sink in the water? Do you think certain items will float in the water? Just because it's bigger, does that mean it will sink to the bottom? Just because it's smaller, does it mean it will float? So again, when I'm talking about density is our big vocabulary word for today. I'm talking about how compact or close together those molecules are in an object. So let's start out with the basketball. It's bigger, but I'm going to take a minute and think, what's inside this? This is not a real basketball that Mr. Lodovico would use. It's got Abrams' name on it there. It's real soft when I squeeze it like this. It even has a spot where I could use a pump for air to put inside here. So it looks like air would be the only thing that's inside this, other than we have the outside rubbery shell. So do you think the basketball will float or sink? I'm going to put it right up like this. Gently let it go. Alright, basketball floated. I don't think we're too surprised there. Let's try something else. I've got a cap eraser. Now it's a little tiny, and when I see it, it does have a hole in it, but it's definitely thicker up towards here. I wonder how those molecules are at the top part of this eraser. Are they packed really close together, or are they spread out? So I'm going to drop my cap eraser next and see what will happen. Think real quick in your head. Is it going to fall all the way to the bottom, or will it float? Remember, it's just a teeny little cap eraser here with a smiley face. It sunk all the way to the bottom. I don't know if you can see it as well here. It is definitely there. It's not floating at the top. It is down right there in the corner. So the cap eraser sank. Let's try ping pong ball. Let's see what happens here. Smaller than the basketball, but again, ping pong ball, there's not very much inside it. It's not thick all the way through. So I'm going to let it go. Ping pong ball floated. So 2 have floated so far, and the cap eraser has sank. Alright, let's move on to the marble, which is right here. Now it is really small, but does that mean it's going to float? It's smaller than the ping pong ball and the basketball there. But I want to think about the molecules inside. How packed close are they? Because density has something to do with how heavy something is for its size, too. So I'm going to drop my marble in very carefully here. I might try and move my paper towels out of the way. That way, hopefully we can see it a little better. Marble sank too. It's rolling around on the bottom. So that tiny marble sank, but the huge basketball and the larger ping pong ball didn't sink. Let's go with a tiny toothpick here. Now this toothpick is wooden. It's made of wood. So I'm going to push these guys out of the way a little bit. I don't know if you can tell or not, but it's definitely still floating. It did not sink to the bottom there. I wonder if I grab this camera. I don't know. If you get motion sickness, let's try and grab it. It won't go that far. Let me see. Sorry about my bald head. I'm moving it real close. There's the marble. And if I move it up, I can see that's a cool shot. I like how the toothpick is still floating there. So the toothpick, the basketball, and the ping pong ball are definitely floating. This is not trick photography. And the marble has sank to the bottom. And I think that's it so far. I will move this back. I think I want to try the cans of pop now. Let's see if I can move this down a little bit. There we can see them. So I'm going to take these out for now, just so it's not too cluttered. So I'm going to start with the Wild Cherry Pepsi first. And let's see if we can move this up. I want to move my cart as close as I can without spilling water all over the computer. I've got my Cherry Pepsi. It's got 42 grams of sugar inside it, 160 calories. Let's see what this can of pop does. It's moving a little bit at the bottom, but it definitely sank to the bottom there. I can still see it. It's kind of floating a little bit off of the bottom there, but definitely still touching. Not floating to the top like the rest of them are. So I've got my Coke Zero can now. Same way. Ooh, let's try and move it this way here a little bit. I see it floating at the top. Interesting. The Coke Zero, the Diet Cola, floated, whereas the Wild Cherry Pepsi Pop sank to the bottom. And yeah, I still call it pop. I live in Western PA, so you can call it soda if you'd like. I'm calling it pop here. So my Diet didn't sink to the bottom, but my very sugary, higher calorie pop did. I wonder if that has something to do with it. Like, the more sugar, does that make it heavier? Does it make it more dense? Now I've got my pine cone. Let's see what happens with my pine cone. I actually picked this from one of the pine trees at Biz last week. Pine cone did not sink. Now let's think about how dense the pine cone is. Is it super compact, or is it kind of spread out a little bit? I've got my gourd here. Mrs. Keir loves getting fall decor around the house. I took one of her gourds in the name of science. I want to see if it will sink or float. But before I do that, let's think about what's inside a gourd. It's like a pumpkin. You know, pumpkins are gourds too. So inside a pumpkin, there's the seeds in there, there's like those guts, there's water inside it. Take a second, what do you think is going to happen when I put the gourd in? This is pretty big. It's heavy too. Looks like the gourd also floats. And I think that's because there's water in it. It's less dense. I'm going to pull it out. I have a big boy gourd here. This looks crazy. It almost looks like a star or an alien. It's definitely heavier than this one. But let's see what happens. Whoa, look at that. It still floats. Even though it's pretty heavy. It's heavy. Was it heavier than the marble? I think so. That's interesting. So the marble, even though it's lighter, still sinks to the bottom. The gourd, or the marble wasn't lighter, the marble's lighter, it sinks to the bottom. The gourd is heavier and yet it still floats. Alright, for my next part of the experiment, I have a balance here, which I did drop on the floor on my way over, FYI. And what I want to do is I want to compare Play-Doh and water. So I have a container of Play-Doh here. It's completely full. And looks like a brand new container. I'm going to take some out. Make it into a little ball. And let's see what happens when I drop it in the water here. I'm going to drop it here. I think you can still see. Will it sink or float? Straight down to the bottom. I think I can see it wiggling around on there. So the Play-Doh sank to the bottom. Well, what I want to do is I have an empty Play-Doh cup here, just a little bit of pieces in. I'm going to fill my cup up with water. I'll leave that Play-Doh in. We'll grab it. If I can catch it here. So I've got a cup of just water here. You can see it inside. And it's filled to the brim. And I've got my Play-Doh. I'll dry this piece off. And it's filled to the brim. Let's use our balance and see what weighs more. They're both filled to the top. Move this so we can see it a little better. So I've got my Play-Doh on this side and my water on the other. I'm going to lay my Play-Doh down here. And I'm going to put the water on that side. Play-Doh is definitely heavier than the water. So whether an object sinks or floats in the water doesn't just depend on its weight or size, it also depends on its density. Density is that measure of how solid something is. All things are made of those tiny particles I call molecules. If the molecules inside an object are very close together, the item is solid or dense. If the molecules are farther away, the object is less dense and less solid. So the water, remember we said the water molecules were pushed real far away? It's going to be less dense than the solid molecules of the Play-Doh. So it's the same amount, but yet the Play-Doh is heavier, even though the containers are exactly the same size. The Play-Doh is heavier. The Play-Doh is more dense than water. So since that Play-Doh is more dense, it would drop all the way to the bottom there. Now the water is in that container. I'm going to take my Play-Doh out. Probably get this under my fingernails too, but that's okay. Alright, empty container. I'm going to take half of my Play-Doh, tear it in half. Looks about the same. Put half in. Right now, the water weighs more than nothing. I want to see if that changes if I have half. Ooh, so the water still weighs more than that. If I put a little more in, let's see what happens. I'll put the Play-Doh on. So even with less than a full container, the Play-Doh is still more dense than a full container of water. So that's just kind of just showing that density is a measurement for how compact, how close together those molecules are. The molecules in the Play-Doh are more closer together than the water molecules are. Even when we did our molecule dances in first grade, we saw that the water ones would be more spread out, the solid ones more tightly packed together. So even when I use the scale to see the balance here, I have less Play-Doh. I still have some extra here. It's still heavier than a full container of water. So I hope you guys learned a little bit more about density and how it has something to do with how heavy something is and how tightly packed the molecules are. It's a fun experiment to try at home. Put different things in the sink, maybe see if they'll float or sink. Definitely make sure you get the okay from your parents. Don't put anything electric in the water. You'll be very hurt if you do. And make sure everybody's okay under adult supervision if you try it. Thanks so much for watching, guys.